There is something almost miraculous about honey, a natural golden liquid so perfectly engineered by nature that it never spoils, so chemically complex that scientists are still discovering new compounds within it, and so nutritionally rich that it has served as both food and medicine across every major human civilization for tens of thousands of years. But the honey that arrives in that jar on your kitchen shelf did not travel a simple road. Between the moment a forager bee draws nectar from a flower and the moment that golden liquid pours over your morning toast, an extraordinary journey unfolds, one that passes through one of the most fascinating and precisely engineered production processes in the entire food industry. Today, we are going inside a modern honey factory to show you exactly how it happens, step by remarkable step. It begins, as all honey does, with the bee. When a honeybee egg hatches inside the hive, out comes a small white larva, legless, featureless, utterly dependent on the colony around it. Those hexagonal wax cells that make up the honeycomb are not just beautiful geometric structures. They are one of nature's most efficient engineering solutions, perfectly shaped to maximize storage space, minimize the amount of wax needed to build them, maintain structural integrity under the weight of stored honey, and regulate temperature within the hive with remarkable precision. Every drop of honey that eventually reaches a factory begins its life protected inside one of those cells. The forager bees responsible for honey production are among the hardest working creatures on Earth. Each one ventures out from the hive dozens of times daily, flying up to 5 miles in any direction to find flowering plants in bloom. When they locate a rich nectar source, they use their long specialized tongues to draw the nectar from the flower and store it in their honey stomach, a dedicated organ completely separate from their digestive stomach, designed specifically for transporting nectar back to the hive without it being digested along the way. A single forager bee can carry a load of nectar nearly equal to her own body weight on each trip, and she will make that trip over and over again through every hour of daylight during the peak of the season. Back at the hive, that nectar is passed from bee to bee in a process that does far more than simply move the liquid from one place to another. Each transfer adds enzymes, most critically the enzyme invertase, which begins breaking down the complex sucrose in the nectar into the simpler sugars, glucose, and fructose that give honey its distinctive sweetness and stability. Simultaneously, bees fan the filled cells with their wings continuously, evaporating water from the nectar and reducing its moisture content from around 80% when it first arrives to below 20% in the finished honey. That reduction in water content is what makes honey shelf-stable. It is what allowed archaeologists to find 3,000-year-old honey in Egyptian tombs still perfectly edible. Once the moisture level is right, the bees seal each cell with a thin layer of beeswax, and the honey is complete. Harvesting that honey is where the human side of this story begins, and doing it properly requires both skill and genuine respect for the colony. Before opening any hive, experienced beekeepers prepare their smokers' devices that burn natural materials like wood chips, pine needles, or burlap, and produce a cool, dense, white smoke. Pumping this smoke gently across the hive entrance and under the lid serves two critical functions simultaneously. It masks the alarm pheromones that guard bees release when they sense a threat, preventing the chemical signal that would trigger a defensive response from spreading through the colony. And it triggers an ancient survival instinct in the bees. When they smell smoke, they instinctively begin gorging on stored honey, preparing to flee what they perceive as an approaching forest fire. A bee with a full honey stomach is a calm bee, and calm bees allow the inspection and harvesting process to proceed safely and efficiently. The beekeeper then carefully removes frames from the hive one by one, examining each one to confirm it is ready for harvest. A frame is ready when the majority of its cells are cap-sealed with that thin layer of white beeswax that indicates the honey inside has reached the correct moisture level. Frames with significant areas of uncapped honey are returned to the hive to continue drying. Qualified frames are gently cleared of bees using a soft brush or a targeted burst of air from a bee blower, then placed immediately into sealed transport boxes that prevent bees from following the honey and reclaiming it. On the world's largest commercial honey operations, this harvesting process happens simultaneously across hundreds or even thousands of hive locations, with teams of workers moving systematically through hive yards, clearing and boxing frames with practiced efficiency. The sealed boxes are then loaded onto trucks and transported to the central processing facility, the honey factory, where the real transformation begins. When those boxes arrive at the factory, the first thing that happens is sorting and inspection. Workers examine incoming frames for quality, separating fully capped frames from any that slipped through the field inspection with too many open cells. Honey from different floral sources is kept strictly separate at this stage because the variety of flower the bees foraged on has a profound effect on the color, flavor, aroma, and chemical composition of the resulting honey. And blending happens later under controlled conditions rather than accidentally at the intake stage. The first major processing step is uncapping, removing the thin beeswax seal that covers each cell and prevents access to the honey inside. In small operations, this is done by hand with a heated uncapping knife, a long flat blade warmed to a temperature that glides cleanly through the wax without melting down into the honey beneath. But in a modern large-scale factory, hand uncapping has been almost entirely replaced by automated uncapping machines of extraordinary efficiency. These industrial units move frames through a set of heated oscillating blades or high-speed rotating chains that strip the wax caps from both sides of every frame simultaneously, processing dozens of frames per minute with a consistency no human hand could match. The beeswax removed during uncapping falls into collection troughs beneath the machines, where it drains of residual honey and is collected for processing separately. Beeswax is a genuinely valuable commodity in its own right, used in cosmetics, pharmaceuticals, candle making, wood finishing, leather care, and dozens of other industrial applications, and a large honey operation recovers significant quantities of it during every harvest season. Nothing in this process is wasted. From the uncapping machines, the frames move into the extraction drums, the mechanical heart of the honey factory. These are large stainless steel cylinders, ranging from compact units that hold a dozen frames for a mid-size operation to enormous industrial radial extractors that can process over 100 frames in a single load. The frames are loaded into a circular rack inside the drum with the honeycomb facing outward, and then the drum begins to spin. Centrifugal force is the mechanism at work here, and it is elegantly simple. As the drum accelerates, the honey inside each cell is flung outward against the inner wall of the drum, where it runs down in thick golden sheets and collects at the base. A well-operated industrial extractor can remove close to 100% of the honey from a fully capped frame in just a few minutes. And because centrifugal extraction pulls the honey out without destroying the wax comb structure, the empty frames can be returned directly to the hives after processing. The bees will clean them, make minor repairs, and begin filling them with honey again, almost immediately, a cycle of remarkable efficiency that has made centrifugal extraction the dominant method in commercial honey production worldwide. As honey collects at the base of the extractor, it flows out through large stainless steel gates into a holding sump below the machine. From there, it is pumped through the first stage of filtration, a series of progressively finer mesh screens that remove the larger particles of wax, propolis, bee debris, and other material that came along with the honey during extraction. This initial coarse filtration does not remove pollen or fine particles. It simply clears the honey of the larger debris that would make it visually unappealing and texturally unpleasant without affecting any of its natural properties. The honey that emerges from initial filtration is raw, complex, and alive with the natural enzymes, pollen grains, trace minerals, and aromatic compounds that give it its distinctive character. It is also still warm from the extraction process, which keeps it fluid and easy to pump and handle. And the journey it is about to take through the factory, through settling tanks and advanced filtration systems and quality testing laboratories and temperature-controlled storage, is one that will ultimately determine what kind of honey ends up in the jar that reaches you. That journey continues in Part 2, where we go inside the settling tanks, the quality laboratories, the bottling lines, and the remarkable range of honey products that modern factories produce from this single extraordinary natural ingredient. Drop a comment right now and tell us, what is your favorite type of honey? We want to know before we take you into the second half of this factory floor. After the raw honey clears the initial filtration screens and flows into the factory's holding system, it enters what might be the least dramatic but most critically important phase of the entire production process, the settling stage. Large stainless steel settling tanks, some holding thousands of gallons of honey at a time, receive the filtered honey and hold it at a carefully controlled temperature for anywhere between 24 and 72 hours, depending on the variety being processed and the final product specification. It is destined for. During this resting period, something quietly essential happens. Air bubbles incorporated into the honey during extraction, and pumping rise slowly to the surface and dissipate. Fine particles of wax too small to be caught by the filtration screens float upward and collect in a layer of foam at the top. The honey below clarifies, stabilizes, and settles into the clean, dense, flowing consistency that makes it ready for the next stage of processing. Workers, or automated skimming systems, remove the foam layer from the surface of the settling tanks regularly throughout this period, and what remains beneath is honey that is visually clear, structurally stable, and ready to be tested. Because in a professional honey factory, nothing moves forward from the settling tanks to bottling without passing through the quality laboratory first. This is non-negotiable, and the testing that happens at this stage is far more rigorous and scientifically sophisticated than most consumers ever imagine when they pick up a jar of honey at the grocery store. The quality laboratory of a modern honey processing facility is equipped to measure and analyze honey across a remarkable range of parameters. Moisture content is the first and most fundamental test. A sample from each batch is analyzed using a refractometer, an optical instrument that measures how light bends as it passes through the honey, which correlates directly to water content. The target is below 20%, with premium producers aiming for 18% or lower. Honey above the moisture threshold is rejected for long-term storage and either processed immediately or blended carefully with drier batches to bring the overall moisture level into the acceptable range. Sugar composition analysis follows. Honey is primarily glucose and fructose in varying ratios depending on the floral source, and understanding that ratio matters enormously for predicting how the honey will behave over time. Honey with a higher glucose to fructose ratio crystallizes faster, which is neither good nor bad in itself, but must be managed appropriately depending on the intended product. Acacia honey, for example, is extraordinarily high in fructose and resists crystallization almost indefinitely, which is why it is prized for applications where long-term liquid clarity is important. Rapeseed honey, on the other hand, is so high in glucose that it begins crystallizing within days of extraction, and this property is deliberately exploited in the production of creamed honey. Hydroxymethylfurfuryl content, known in the industry simply as HMF, is another critical measurement. HMF is a compound that forms naturally in honey over time and at an accelerated rate when honey is exposed to heat. Low HMF levels indicate fresh honey that has been handled at appropriate temperatures throughout processing. High HMF levels signal either aged honey or honey that has been overheated at some point in the supply chain, both of which are considered quality defects in most markets. International standards set maximum acceptable HMF levels, and batches that exceed those limits are rejected regardless of how they look or taste. Enzyme activity testing measures the diastase and invertase activity remaining in the honey naturally occurring enzymes that are present in fresh honey but degrade when honey is exposed to excessive heat. Because these enzymes are one of the markers that distinguish genuine natural honey from adulterated or heat-damaged product, their presence at meaningful levels is an important quality indicator, particularly for honey marketed as raw or minimally processed. Pollen analysis is perhaps the most revealing test of all. Every batch of honey contains microscopic pollen grains from the flowers the bees visited, and examining those grains under a microscope tells a trained analyst an extraordinary amount about the honey's origin. The floral composition of the pollen profile confirms whether a honey labeled as monofloral from a single flower source actually matches that description. The geographic pollen signature can indicate the region or even the country of origin, which matters enormously in an industry that has been repeatedly troubled by mislabeling and fraudulent origin claims. In markets where honey adulteration with cheap sugar syrups has been a documented problem, pollen analysis combined with isotope ratio testing provides the scientific foundation for authenticity verification that both regulators and premium buyers demand. Only after all of these tests have been completed, analyzed, and confirmed does a batch of honey receive clearance to move forward through the factory. And when it does, the next destination depends entirely on what product it is destined to become, because a modern honey factory does not produce just one product, it produces dozens. For honey destined for retail bottling as liquid honey, the cleared batch moves from the settling tanks into the blending room. Commercial blending is one of the most skilled and least discussed arts in the honey industry. Because the flavor, color, aroma, and viscosity of honey varies significantly from season to season and region to region, even within a single floral variety, producing a product that tastes and looks identical year after year requires combining honeys from multiple sources in precisely calculated proportions. Master blenders taste and evaluate individual batches the way a wine blender evaluates base wines, identifying the characteristics of each component and calculating the combination that will match the established flavor profile of a particular brand or product line with the closest possible accuracy. Once the blend is finalized, the honey moves to the temperature management stage. Maintaining honey at the right temperature through the final stages of processing is one of the most carefully controlled variables in the entire facility. The target temperature range for liquid honey heading to the bottling line is typically between 35 and 40 degrees Celsius, warm enough to keep the honey fluid and easy to pump and fill without creating air bubbles, flow irregularities, but cool enough to avoid the enzyme degradation and HMF increase that higher temperatures would cause. Getting this balance right requires precision heating systems in the holding tanks and insulated piping throughout the facility, and the best factories invest significantly in these systems because the quality difference between honey handled at the right temperature and honey that got too hot at any point in the process is measurable in the laboratory even when it is invisible to the eye. The bottling line itself is where the factory's industrial efficiency becomes most visually impressive. Empty jars arrive from the packaging warehouse on automated conveyor systems and are fed into the filling machines in a continuous procession. These are gravimetric or volumetric filling units of extraordinary precision machines calibrated to fill each jar to within a fraction of a gram of the specified weight, adjusting automatically for variations in honey viscosity and flow rate to maintain that consistency across thousands of jars per hour. The filling nozzles are designed to minimize splashing and air incorporation, delivering the honey in a smooth, controlled stream that fills each jar cleanly from the bottom up. From the filling station, the jars move to automated capping heads that place and torque each lid to an exact specification tight enough to create an airtight seal that will maintain the honey's quality through its shelf life, consistent enough that every jar opens with the same resistance in the consumer's hand. Incorrectly torqued lids, too loose or too tight, are detected by inline sensors and automatically diverted from the line before they can continue to labeling. The labeling station applies printed labels with a speed and precision that is remarkable to watch. Each jar receives its label perfectly positioned and aligned, and immediately after labeling, a high-speed inkjet printer applies the variable information production date, best before date, batch number, and barcode directly onto the label or onto a designated area of the jar. That batch number is the thread that connects every jar back through the entire production record to the specific blend, the specific settling tank, the specific extraction session, and ultimately, the specific hive yards where that honey was harvested. Full traceability from shelf to hive is the standard that serious producers maintain, and it is the foundation of the quality guarantees they make to their customers. Not all honey leaving the factory goes into conventional liquid form. Creamed honey, one of the most popular honey formats in Canada, Scandinavia, and increasingly across global premium markets, is produced through a completely different processing pathway that exploits rather than prevents crystallization. A small quantity of previously crystallized honey with a very fine crystal structure is used as a seed, blended into liquid honey at a precise ratio, and then held at a cool temperature of around 14 degrees Celsius for several days. The seed crystals grow throughout the batch, but because the seed crystals are extremely fine, the crystals that form in the finished product are also fine, too small to feel grainy on the tongue, producing a smooth, spreadable, dense texture that many consumers find superior to liquid honey in both flavor intensity and ease of use. Creamed honey production requires its own dedicated equipment, separate temperature-controlled rooms, and careful management of the seeding ratio and holding temperature, but the premium price it commands in most markets makes that investment worthwhile. Comb honey sections of actual honeycombs still in the wax. Exactly as the bees produced, it requires almost no factory processing at all, beyond careful cutting, weighing, and packaging. It commands the highest prices in the specialty honey market precisely because of its absolute naturalness and the skill required to produce perfect, unbroken sections of capped comb. Factories that handle comb honey sections invest in specialized cutting equipment and packaging systems designed to protect the fragile wax structure through transport and retail display. Honey sticks, honey sachets, and the increasingly popular honey spoons, where honey is molded into a spoon shape using food-grade molds and sealed with film or foil, represent the convenience end of the product range. These formats are produced on dedicated packing lines that portion honey into precisely controlled small quantities and seal each unit individually, creating a mess-free single-serve format that has found enormous success in the food service, travel, and retail gifting markets. The honey spoon in particular has become a premium product in its own right, with artisan producers offering single-origin varietal honey spoons that deliver a tasting experience as considered and specific as a fine chocolate or specialty coffee. Before any finished product leaves the factory floor, one final quality check takes place at the packaging stage. Inline vision systems scan every jar, every sachet, every sealed unit for fill level, cap integrity, label placement, and print quality. Units that fall outside specification in any parameter are automatically rejected and diverted to a rework area rather than continuing to the outbound warehouse. The standard is not most jars being right. The standard is every jar being right, because in a market where consumers have more choice and more information than ever before, a single compromised jar can undo years of carefully built brand reputation. What leaves the loading dock of a modern honey factory and moves into the global distribution network is the product of an almost incomprehensible collaborative effort. Millions of bees making billions of individual trips to flowers across thousands of acres of landscape. Beekeepers managing those colonies through every challenge the season brings. Extraction teams working through peak harvest with precision and speed. Laboratory technicians running tests that would not have been possible a generation ago. Blenders applying skills that take years to develop. Engineers maintaining equipment that operates around the clock through the production season. And quality teams whose entire purpose is ensuring that not a single jar leaves the building that is not exactly what it claims to be. That jar of honey sitting in your kitchen right now traveled all of that distance, passed through all of those hands and systems and tests, carried within it the work of creatures that have been making honey since long before the first human being walked the earth. The factory made it accessible, consistent, safe, and shelf-stable. But the honey itself, that golden, complex, ancient, extraordinary substance that was made by the bees, it always was. It always will be. If you found this journey through the modern honey factory as fascinating as we did putting it together, drop a comment below and let us know which part of the process surprised you most. Hit that like button, subscribe to the channel, and stay with us, because there is always something extraordinary waiting in the next video.